Good morning, students. In the previous class, we discussed about the colligative properties. What is meant by colligative properties? We are discussed in the previous class. Along with, we are discussed about the four colligative properties, that is the relative lowering of vapor pressure of a solvent and elevation of boiling point of the solvent. And the third one is depression of freezing point of the solvent, and the fourth one is osmotic pressure of the solution. And along with, we are discussing in the previous class what is meant by lowering of vapor pressure. Means the lowering of vapor pressure is the difference between the vapor pressure of the pure solvent and the vapor pressure of the solution. This we call as a lowering of vapor pressure. This depends on the number of solute particles, but it does not depends on their nature. Therefore, the lowering of vapor pressure, the relative lowering of vapor pressure is a colligative property. This we are discussed in the previous class. In this class, we are going to be discussing about the first colligative property, that is relative lowering of vapor pressure. We are going to be discussing now, that is the relative lowering of vapor pressure. In the previous class, lowering vapor pressure andre ಏನು ಅಂತ ಗೊತ್ತಾಯಿತು. Now we are going to be discussing about that. Just now you should consider, let us consider the solution obtaining by the, that is N2 moles, that is N2 moles of solute, that is N2 moles of solute dissolved in N1 moles of solvent. N1 moles of solvent. Then we can be written as the mole fraction of this. We can be written as, that is chi2 is equal to, that is N2 divided by N1 plus N2, and chi1 is nothing but, that is the N1 divided by N1 plus N2. This we are going to be taken as 1. This is the equation 1. This is the equation 2. We can be written as equation 1 and equation 2. Here, always it is a solute is a non-volatile solute. Therefore, the vapor pressure of the solute is negligible. The vapor pressure of the solute is negligible. Really, solution andre ಏನು ಹೇಳಿದ್ವಿ? Solution is nothing but it is solvent plus solute. Vapor pressure ಏನಾಗಿರುತ್ತೆ? The solute negligible ಆಗಿರುತ್ತೆ. ಯಾಕೆ negligible ಆಗಿರುತ್ತೆ? It is a non-volatile solute. Non-volatile solute ಆಗಿರೋದ್ರಿಂದ vapor pressure ನಾವು neglect ಮಾಡಬಹುದು. Therefore, the vapor pressure of the solvent is equal to the vapor pressure of the solution. Is equal to the vapor pressure of the solution. According to Rolle's law, the vapor pressure of the solvent is given by, according to Rolle's law, that is P1 is equal to, that is chi1, that is chi1 P1 naught. Here, where the P1 naught is nothing but, that is vapor pressure of, that is vapor pressure of, that is pure solvent. The vapor pressure, that is P1 naught is nothing but vapor pressure of a pure solvent. This we know that is now we can be written as, then you can take this the equation 3. You can take the equation 3. That is now, that is the chi1 plus chi2. The mole fractions of these two components is going to be unity. Then the chi1 we can be written as, the chi1 is equal to 1 minus chi 2. 1 minus chi 2. This is going to be equation 4. Equation 4. Substitute. That is substitute 4 in 3. 4 in 3. At that time, the P1 is equal to, that is 1 minus chi 2. 1 minus chi 2. 1 minus chi 2. That is P1 naught. P1 naught. Then we can be written as, that is going to be, that is the P1 divided by P1 naught is equal to 1 minus chi 2. This we can be written like this. Then chi 2 is equal to, chi 2 is equal to 1 minus, that is P1 divided by P1 naught. This we can be written as, taking the P1 naught as an LCM, then we can be written as 1 minus, that is P1 naught minus P1. This we are going to be taken as a chi 2. Then chi 2 is equal to, then this we can be written as delta P1. We can be written as, this has delta P1 is equal to P1 naught minus P1. Then we can be written as, that is chi 2 is equal to, that is P1 naught, then P1 divided by, otherwise we can directly write, that is delta P1, that is change in the vapor pressure divided by the, that is the P1. Then we are going to be taken as a P1 naught. Means this is the equation, you can be written as equation 5. This is equation 5. This is the equation 6. Then equation 6 and 5 we can be written as, from equation 5 and 6 we can be written as, that is delta P1 divided by P1 naught is equal to P1 naught minus P1 divided by, that is P1 naught, that is equal to chi 2. This about the mole fraction of the solvent, that is here mole fraction of the solute, that is going to be change in the vapor pressure, that is going to be written like this. In this we can be written as, this we called as a, that is we can be written as, then that is P1 naught minus P1 divided by the P1 naught is called relative lowering of vapor pressure. Relative lowering of vapor pressure. Vapor pressure means this we can be written as, this we call as the relative lowering of vapor pressure. Once again I will explain. That is the N2 moles of solute dissolved in a N1 moles of solvent. At that time, the mole fraction of, that is solute, we can be written as N2 divided by N1 plus N2. Then chi 1 is equal to, that is N1 divided by N1 plus N2. This we are going to take as 1 and 2. According to Rolle's law, we can be written as, that is P1 for ideal solution, we can be written as P1 is equal to, that is chi 1 P1 naught. Here P1 naught is nothing but vapor pressure of the pure solvent. Then we know that, that is some of the mole fractions of the components is equal to the unity. That we know that. That is we can be altering this equation, that is chi 1 is equal to 1 minus chi 2. This we are going to be substituting in the equation 3. At that time we are going to be get that the P1 is equal to 1 minus chi 2 into P1 naught. This we are altering. This P1 naught we are going to be taken this side. Then P1 divided by P1 naught is equal to 1 minus chi 2. Chi 2 is equal to 1 minus P1 by P0. Then this we are going to be taken LCM. The P1 naught is P1 naught is LCM. Then P1 naught minus P1 divided by P1 naught we are going to be getting. From this to this we can be written as delta P1, but that is nothing but the change in the vapor pressure that we are going to be represented by the delta. Delta is nothing but change in the vapor pressure. Then from the equation 5 and 6 we can be written as delta P1 divided by P1 naught is equal to P1 naught minus P1 divided by P1 naught is equal to chi2. Is nothing but this we call as a relative lowering of vapor pressure. For this then we can be written as, that is chi2 is nothing but mole fraction of the solute. That is this also we can be written as this also be this we got there is the P1 naught is equal to x2. Then that is we can be written as, that is the P1 naught, that is going to be, we can be taken as, that is P1 naught minus P1 divided by the P1 naught is equal to chi2. We know that chi2 is nothing but, that is the P1 naught minus P1 divided by P1 naught is equal to, that is N2 divided by N1 plus N2. In this we can N1 and N2 are the number of moles of the solvent and the solute molecules. In this respectively, the dilute solution, the N2 is, for the dilute solutions, N2 is much lesser than the, that is going to be more lesser than the, that is the N1. Therefore, N2 is going to be neglected. N2 is going to be neglected in the denominator. Then we can be written as, N2 is going to be neglected in the denominator. We can be written as, that is P1 naught divided by P1 divided by P1 naught is equal to, that is N2 divided by N1. N2 divided by N1. This about the relative lowering of vapor pressure. In this, that is in this what we are written, that is chi2. The chi2 is nothing but mole fraction of the solute, that we can be written as N2 divided by N1 plus N2. For the dilute solutions, dilute is tumba dilute agiro solutions. And solvent is more. The solute is very less. At that time, we are going to be taken as N2 is much lesser than N1. At that time, N2 is neglected in the denominator. We are going to be get that N2 divided by N1. Like this only we will discuss how to calculate the molar mass of the solute by using this. We will be discussing now. Is determination of molecular mass of solute from the relative lowering of vapor pressure. Relative lowering of vapor pressure in the now determination of that is the molecular mass of the solute. This we are going to be done by, that is let us consider that is W 2 grams of solute dissolved in W1 gram of solvent and the M1 and M2 are the molecular masses of solvent and solute respectively. According to Rolle's law. We are going to be taken as according to Rolle's law. We are going to be taken as, that is the P1 naught minus the P1 divided by the P1 naught is equal to, that is we are going to be get that N2 divided by N1. That is we can be written as the P1 naught minus the P1 divided by the P1 naught is equal to, that is N2 is nothing but we can be written as, that is N2, before going to that we can be written as the N2 is nothing but, that is the W2 divided by M2, that is the number of grams of solute divided by molar mass of the solute. Then N1 is nothing but we can be taken as, that is W1 divided by M1. This we are going to be substituting in this equation 1. Substitute in equation 1. At that time we are going to be get that the P1 naught minus P1 divided by the P1 naught is equal to, N2 is nothing but W2 divided by M2. W2 divided by M2. Then N1 is nothing but W1 divided by, that is M2. That we are going to W1 divided by M1. Then we are going to be get that, that is we can be written as, that is W2 divided by M2 into, that is M1 divided by W1. This we can be written as the P1 by P1 naught is equal to, that is W2 M1 then M2 divided by W1. By using this formula we can calculate the molar mass or molecular mass of the solute. This is about the determination of molecular mass of solute from the relative lowering of vapor pressure. We know the remaining factor, we can be calculate the molecular mass of the solute. Here you should be, let us consider, that is W2 gram of that is solute is dissolved in W1 gram of solvent, and M1 and M2 are the molecular mass of the solvent and solute respectively. According to Rolle's law, we can be written as the P1 naught minus P1 divided by P1 naught is equal to N2 divided by N1. The N2 is nothing but W2 divided by M2 is nothing but number of moles. The formula used here, number of moles is equal to mass divided by molecular mass. That we have written here. That is N1 is nothing but W1 divided by M1. Then substitute in the equation 1, we are going to be get like this. This on rearranging, we are going to be get this formula. This formula is used to find the molecular mass of the solute. The next we will discuss about the problems based on this determination of molecular mass of the solute from the relative lowering of vapor pressure.